They were convinced their tanks were invincible. The Type 95 Hago had proven itself against Chinese forces, against Soviet armor at Hulkan Gol, and in the sweeping victories across Malaya and the Philippines. Japanese tank crews believed their light tanks represented the pinnacle of armored warfare design, perfectly suited for the jungles and islands of the Pacific. They had crushed every enemy they encountered. They were wrong. The story of how they discovered this begins not with defeat, but with confidence born from years of success. The Hago was no accident of design. It was the product of careful military planning that began in 1933 when the Japanese Imperial Army recognized a critical gap in its armored forces. The Type 89 medium tank, Japan's workhorse, could only manage 15 miles per hour. This was adequate for supporting infantry at walking pace, but utterly inadequate for the mechanized warfare the Army envisioned. Japanese military planners had watched with interest as other nations developed faster, more mobile armored forces. They wanted a tank that could keep up with motorized infantry moving at 40 miles per hour, that could navigate the terrain of Manchuria and China, and that could be produced in quantities their industrial base could sustain. The Army Technical Bureau issued specifications in July 1933. The new tank would weigh approximately 7 tons, mount a 37mm gun, achieve speeds of 40 kilometers per hour, and have armor sufficient to resist rifle and machine gun fire. Most importantly, it would be simple to manufacture and maintain. Mitsubishi Heavy Industries received the contract. Engineer Tomihara, who had already made a name for himself designing the Type 89, took on the challenge. His most notable innovation was the bell crank suspension system, a simple yet effective design that would become standard on Japanese tanks for the next decade. By June 1934, Mitsubishi had completed the first prototype. The prototype impressed military observers during field trials conducted in Manchuria and at proving grounds in Japan. It was fast, reaching 45 kilometers per hour on paved roads and maintaining 25 to 30 kilometers per hour cross-country. It was maneuverable, with a turning radius that seemed impossible for a tracked vehicle of its size. The Har suspension, with its distinctive bell crank design, absorbed shocks well and allowed the tank to traverse rough terrain that would have stopped other vehicles. And it was mechanically reliable, using a Mitsubishi 6-cylinder air-cooled diesel engine that produced 120 horsepower at 1,800 revolutions per minute. The diesel engine was a particular point of pride for Japanese engineers, making the tank less vulnerable to fires than gasoline-powered vehicles. Diesel fuel was also more readily available in Japan's empire, particularly in areas like Manchuria and Southeast Asia, where gasoline supplies were limited. The engine could run for 8 to 10 hours on its internal fuel capacity of 34 gallons, giving the tank an operational range of approximately 130 miles on roads. Trials revealed some problems. The suspension had a tendency to pitch violently on rough ground, making aiming while moving nearly impossible and causing crew fatigue. Engineers addressed this by adding braces to connect the bogie pairs, creating what became known as the Manchurian suspension. The modification helped but did not completely eliminate the rough ride that would characterize the Hago throughout its service life. In 1935, at a meeting in the Army Technical Bureau, the Type 95 was formally presented as the potential main tank for mechanized infantry units. The infantry representatives had concerns. They argued that 12 millimeters of armor was insufficient for a tank that would be supporting infantry assaults against fortified positions. The cavalry representatives countered that the improved speed and mobility compensated for thin armor, and that the tank's firepower was adequate for its intended role. After considerable debate, the infantry agreed to accept the design. The Type 95 Hago was officially of steering lever. The designation came from the Japanese imperial calendar, marking the 2595th year since the legendary founding of Japan. Only the last two digits were used in the type number. Production began at Mitsubishi facilities in 1936. The Hago was indeed a small tank. It measured just 4.38 meters long, 2.06 meters wide, and 2.13 meters tall. In American measurements, that was 14 foot 4 in long, 6 foot 9 in wide, and just under 7 feet tall. A man of average height could look over the turret. The weight came in at 7.4 tons for the basic tank, reaching 8.1 tons when loaded with crew, fuel, and ammunition. The armor was thin by any standard. 12 millimeters at its thickest points on the turret and upper hull, 9 millimeters on the roof and floor, 6 millimeters in some less critical areas. Japanese designers had calculated this was sufficient to stop rifle and machine gun bullets at combat ranges. They were designing for the enemies they expected to fight: Chinese forces with limited anti-tank capability and light Soviet tanks. Inside the tank was cramped. The crew consisted of 3 men. The driver sat in the front left of the hull, with limited vision through a small viewport and periscope. A hull machine gunner sat to the driver's right, operating a Type 97.7 mm machine gun mounted in a ball mount. The commander occupied the turret alone, standing on the whole floor with no turret basket beneath his feet. This commander had perhaps the most difficult job in the Imperial Japanese Army. He had to command the tank, directing the driver, and communicating with other tanks when radio was available. Only 1 tank in 4 had a radio set, leaving the others to follow visual signals. He had to operate the main gun, a Type 94 37 mm cannon capable of firing both high explosive and armor-piercing rounds. He had to load that gun, a physical task made difficult by the cramped space and the need to stand while doing so. And he had to operate a second machine gun, mounted in the rear of the turret, facing to the right rear at roughly the 5 o'clock position. American tankers, who later examined captured Hagos, marveled that anyone could function effectively under such conditions. The Japanese commander had no seat in the turret. He stood throughout combat, his head and shoulders exposed if he opened the hatch for better vision, or confined to a small space with minimal visibility. The turret rotated by hand crank, requiring significant physical effort. There was barely room to move, let alone fight effectively. But in its intended role, against the opponents it was designed to fight, the Hago performed well, very well indeed. The tank first saw significant action in China, starting in 1937 against Chinese forces that had virtually no armor and limited anti-tank weapons. The Hago was devastating. Its 37 mm gun could destroy fortifications and suppress infantry. Its machine guns cut down troops in the open. Its mobility allowed it to exploit breakthroughs and pursue retreating forces. Japanese tank crews gained combat experience and confidence. They learned their trade in an environment where their tanks were clearly superior to anything they faced. This success bred a dangerous assumption that the Hago was a genuinely capable tank rather than a vehicle optimized for a specific limited scenario. The assumption was tested at Kulkan Gol in 1939, where Japanese forces clashed with the Soviet Union along the Mongolian border. Here, the Hargo faced real opposition. Soviet BT-5 and BT-7 tanks mounted 45mm guns with better armor penetration than the Japanese 37mm. Soviet armor was thicker, making frontal engagements difficult for the Hargo. The battles were brutal. On July 2, 1939, the Japanese 3rd Tank Regiment, equipped primarily with Type 95 tanks, attacked Soviet positions. The initial assault achieved some success through aggressive tactics and surprise. Japanese tanks destroyed 32 Soviet tanks and captured 35 armored vehicles. But Soviet counterattacks in the following days revealed the Hargo's vulnerabilities. Soviet guns could penetrate the Hargo's armor at ranges where the Japanese guns struggled to damage Soviet tanks. By the end of the Kholkhin-Gol campaign, Japan had lost dozens of tanks. The lessons were clear to anyone paying attention. The Hargo was outmatched by modern Soviet armor. Its thin protection and relatively weak gun were not adequate for tank versus tank combat against peer adversaries. But these lessons were not fully absorbed. Japanese military leadership focused instead on tactical improvements and crew training rather than fundamental redesign of their armored forces. The war in China continued, and there, the Hargo remained effective. When war broke out across the Pacific in December 1941, Japanese tank units achieved remarkable successes in Malaya. Hargo tanks navigated terrain British commanders thought impossible for armor. They moved through rubber plantations and jungle trails, supporting the rapid Japanese advance down the peninsula toward Singapore. British forces, who had not deployed significant armor to Malaya, were unprepared for this mobile threat. In the Philippines, Hargos landed with the invasion force and supported Japanese infantry operations. On December 22, 1941, north of De Mortis, Type 95 tanks engaged American M3 Stuart light tanks in what would be recorded as the first tank versus tank battle involving U.S. forces in the Pacific. Both tanks mounted 37mm guns. The M3 had better armor, 32mm on the turret sides compared to the Hargo's 12mm. But at close range in jungle fighting, the Japanese achieved some success, destroying one M3 in the initial engagement. These early victories reinforced Japanese confidence. From their perspective, the Hargo was performing exactly as designed. It was mobile, reliable, and effective in supporting infantry operations across diverse terrain. Tank crews trusted their machines. Commanders relied on their armor, and when orders came to defend Saipan, the Japanese brought their tanks without questioning their adequacy. Saipan was different from the battles that had come before. The island in the Mariana Chain was strategically vital, positioned just 1,250 miles from Tokyo. If the Americans captured Saipan, their B-29 bombers would be within range of the Japanese home islands. The empire's leaders knew this. They fortified Saipan with approximately 30,000 troops, nearly double what American intelligence estimated. Among the defenders was the 9th Tank Regiment, commanded by Colonel Takashi Goto. The regiment was equipped with 44 tanks, a mixture of Type 95 Hargos and the slightly larger Type 97 Chiha tanks. The Chihas were better armed, with 57mm guns, but shared the thin armor that characterized Japanese tank design. These tanks represented a significant armored force by Pacific standards, certainly the largest the Americans had yet faced. The Americans began their assault on June 15, 1944. Vice Admiral Richmond Kelly Turner ordered the landing force ashore at 0542 hours. By 0700, landing craft were moving toward the beaches. At 0840, the first wave hit the shore. The 2nd and 4th Marine Divisions landed on Saipan's western beaches under heavy fire from Japanese artillery and mortars positioned on the heights overlooking the landing zones. The Marines fought their way inland against fierce resistance. By nightfall of the 15th, 20,000 American combat troops were ashore. Equipment and supplies poured onto the beaches. Among the equipment were M4 Sherman medium tanks, landing from LST vessels and moving forward to support the infantry. The Marines established a beachhead, but it was not yet secure. Japanese artillery could still reach the beaches. Counterattacks continued through the night. On June 16th, the Marines consolidated their positions and began pushing inland. The 2nd Marine Division worked to close gaps in the line, while the 4th Marine Division cleared areas around key terrain. General Holland Smith, commanding the assault force, committed his reserves, bringing elements of the 27th Infantry Division ashore to reinforce the beachhead. Lieutenant General Yoshisugu Saito, commanding Japanese forces on Saipan, recognized the critical situation. If the Americans consolidated their beachhead and brought their full combat power ashore, dislodging them would become impossible. He needed to strike before they were fully prepared. Saito issued orders for a major counterattack, using the island's most powerful assets, the infantry of the 136th Regiment and the tanks of the 9th Tank Regiment. The order was specific. The infantry would assault the American positions around Karen Kanoa Airfield. The tank unit would advance southwest of Hill 164.6, moving after the infantry attack commenced. The tanks would charge the transmitting station and throw the enemy into disorder before the infantry penetrated the sector. It was an ambitious plan requiring coordination between infantry and armor in a night attack across difficult terrain. Colonel Goto gathered his tank crews. They conducted final maintenance checks on their vehicles. Crews loaded ammunition, 37mm rounds for the Haros, 57mm for the Chihas. They filled fuel tanks, checked track tension, tested the radios on the few tanks that had them. The crews were confident. Many had combat experience from China or earlier Pacific campaigns. They trusted their machines and their tactics. In the pre-dawn darkness of June 17th, the Japanese tank column moved out. Diesel engines coughed to life, their distinctive sound echoing across the pre-dawn landscape. Tracks clanked as the tanks formed up and began their approach toward the American lines. Inside each cramped vehicle, crews felt the familiar vibration and noise of their tanks in motion. Commanders stood in their turrets, trying to see through the darkness, coordinating movement through visual signals. The Americans heard them coming. Marine sentries on the perimeter reported engine sounds from the north. Officers shouted orders. Men grabbed weapons and moved to defensive positions. Anti-tank gun crews traversed their 37mm M3 guns toward the approaching sounds. Sherman tank crews who had bedded down near their vehicles climbed aboard and started engines. Machine gun teams checked their weapons and ammunition. At 0330 hours, the Japanese attack began in earnest. 44 tanks, the largest armada formation yet committed by Japan in the Pacific, advanced toward the 2nd Marine Division's positions. Some tanks carried infantry clinging to the hulls, a dangerous but sometimes effective tactic. The formation moved through the darkness, guided by the lead tanks and following the terrain toward their objectives. Marine riflemen saw them first as dark shapes emerging from the pre-dawn gloom. Then came the distinctive sound of diesel engines at full throttle, tracks throwing dirt and dust, the clank of bogie wheels, and the squeal of steel on steel. Japanese tankers could see Marines in their positions. They could see the defensive line ahead. Some commanders opened fire with their hull machine guns sweeping the ground ahead. Others reserved fire, trying to get closer before engaging. Then something unexpected happened. Something that would fundamentally change how Marines viewed Japanese armor for the rest of the war. Marine machine gunners positioned in foxholes and behind cover opened fire with their Browning M2 heavy machine guns. These were not the standard infantry machine guns, the 30 caliber weapons that provided supporting fire. These were 50 caliber weapons, heavy machine guns designed to engage aircraft and destroy light vehicles. The 50 caliber Browning M2 was a formidable weapon, designed near the end of World War I and perfected in the decades since. It fired a 12.7 mm round at a muzzle velocity exceeding 2,900 feet per second. The standard ammunition load included ball rounds for general use and armor-piercing rounds specifically designed to defeat light armor and fortifications. The armor-piercing variant could penetrate 23 millimeters of face-hardened steel armor plate at 200 meters. At 500 meters, it could still penetrate 19 millimeters. These were not theoretical numbers. They were verified test results confirmed through extensive firing trials at American Ordnance Proving Grounds. The ammunition had been designed to engage lightly armored aircraft and vehicles, not to defeat tanks. But the mathematics of armor penetration are unforgiving. The Type 95 Hargo's armor was 12 millimeters thick at its maximum on the turret front and sides. On the upper hull, the thickest armor on the entire vehicle was 12 millimeters. Simple arithmetic revealed the problem. The 50 caliber armor-piercing round could penetrate nearly twice that thickness at close range. At the ranges where the battle was being fought, 200 meters or less as tanks closed with Marine positions, the 50 caliber had more than enough penetrating power. Marine machine gunners opened fire. Tracer rounds arced across the battlefield in brilliant orange-red lines. The sound was distinctive. The heavy boom, boom, boom of 50 caliber machine guns firing at sustained rate. Gunners aimed at the advancing tanks, some not entirely believing their weapons would be effective against armor. What happened next shocked both sides. The 50 caliber armor-piercing rounds didn't just dent the tanks, they didn't ricochet off at angles, they penetrated cleanly, decisively. At close range, some rounds went completely through the thin armor, entering one side of the tank and exiting the other. Even at longer ranges, the rounds punched through the armor with energy to spare. Inside the Japanese tanks, crews experienced something far worse than defeat. They experienced revelation. The heavy machine gun fire wasn't just loud impacts on the outside of the hull, it was penetration. Rounds coming through the armor. In the cramped interior of a cargo, there was nowhere to hide. A round that penetrated the hull could strike engine components, ammunition racks, or crew members. The face-hardened armor, designed to resist rifle fire, offered no meaningful protection against the heavy 50 caliber rounds. One Marine machine gunner, firing his weapon from a position near the airfield, reported watching his tracer rounds strike a Hargo advancing directly toward him. The rounds hit the front hull, and he could see sparks inside the tank through vision ports and hatches. The tank kept coming for a moment, then slowed, then stopped. Engine smoke poured from the rear deck. The crew attempted to bail out. 2 men emerged. They were immediately engaged by rifle fire from the Marines in foxholes. Another gunner, positioned with his weapon mounted on a half-track, engaged a cargo at approximately 150 meters. He fired a sustained burst into the tank's side armor. The tank turned toward him, exposing more of its flank. He kept firing. His loader fed another belt of ammunition into the gun. He watched the commander in the turret slump forward, then fall. The bullet had gone through the thin turret armor, struck the man, and continued through the other side. The commander never knew what hit him. A third Marine, manning a .50 caliber in a fixed position on the defensive line, engaged multiple tanks as they advanced. He fired at one Hargo's engine compartment, aiming for the rear deck where the cooling vents were located. His rounds penetrated the thin 6mm armor covering the engine. The diesel engine, its cylinders opened by .50 caliber impacts, seized. The tank stopped moving, becoming a stationary target. The crew abandoned it, running back toward Japanese lines through a hail of small arms fire. Japanese tank crews who survived the initial assault couldn't process what was happening. They had trained for years. They had fought in China, where enemy weapons bounced harmlessly off their armor. They had faced Soviet anti-tank rifles at Khalkhin and survived. Their tanks were supposed to protect them. That was the fundamental premise of armored warfare. The tank's armor kept the crew alive while they engaged the enemy with superior firepower. But American machine guns were defeating their armor, not anti-tank guns, firing large-caliber projectiles, not artillery, not even the massive 75mm guns on the Sherman tanks they could see moving into position. Machine guns, infantry support weapons, weapons that were mounted on jeeps, on half-tracks, on every vehicle in the American arsenal. The realization was devastating. If machine guns could penetrate their tanks, what chance did they have? A Japanese tank officer, later captured after his tank was disabled, told American interrogators that his first thought was that the Americans must have developed some new secret weapon, some advanced ammunition or special gun that looked like a standard machine gun but fired exotic projectiles. He simply could not accept that a conventional heavy machine gun could defeat a tank. In his entire combat experience, from training in Manchuria to fighting in China, small arms fire had always been ineffective against armor. Bullets made noise on the outside, they didn't come through. But the Browning M2 was in an entirely different category from anything the Japanese had previously encountered. With its armor-piercing rounds, it had sufficient energy and penetrating power to defeat 12mm armor at any range where a machine gunner could accurately engage a target. And the Marines had these weapons everywhere. They were standard equipment throughout the American military. As the Japanese tank attack faltered under this unexpected fire, Sherman tanks moved forward to engage. The contrast was stark. Where the cargo weighed 7.4 tons, the M4A2 Sherman, the variant used by Marines at Saipan, weighed 31.8 tons. Where the Hargo had 12mm of armor, the Sherman had 51mm on the frontal hull, angled at 56 degrees to provide effective protection equivalent to approximately 75mm against anti-tank fire. The Sherman mounted a 75mm gun as its main armament. This gun could penetrate the Hargo's armor from over a mile away. When Shermans opened fire on the Japanese tanks, the outcome was predetermined. 75mm armor-piercing rounds struck Hargos and Kihas with devastating effect. Tanks were blown apart. Turrets were knocked off hulls. Ammunition detonated inside crew compartments. Japanese tanks that returned fire found their 37mm and 57mm rounds completely ineffective against the Sherman's frontal armor. The shells bounced off or created small dents without penetrating. One Japanese tank commander, whose cargo was disabled by 50 caliber fire, but whose turret could still traverse, attempted to engage a Sherman at close range. He ordered his gunner to fire. The 37mm gun fired its armor-piercing round. The projectile struck the Sherman's turret face. There was a flash of impact. The Sherman didn't even slow down. It continued to rotate its turret with mechanical precision, aimed and fired. A single 75mm round. The cargo exploded. The battle evolved into what one Marine officer later described as a madhouse of noise, traces, and flashing lights. Disabled tanks burned, illuminating other tanks still trying to advance. Infantry that had been riding on the tanks scattered, seeking cover in shell holes and drainage ditches. Some Japanese infantry made it to the Marine lines, fighting desperate close-range battles in and around American positions. Marine infantry, hunkered in their foxholes, found themselves with Japanese tanks passing directly over them. One Marine later reported that a Hargo leaking oil heavily soaked him as it passed over his position. He remained still until it moved on, then emerged and threw a thermite grenade into the engine compartment as the tank moved past. The tank began burning from the inside. Another Marine, lying low in his foxhole as a tank rolled over him, jumped out after it passed and jammed a coconut log into the bogie wheels. The tank spun in place, tracks throwing dirt, unable to move forward. When the confused tank commander opened his turret hatch to see what was wrong, the Marine jumped onto the tank and dropped a thermite grenade into the open turret. The tank exploded from internal fires, igniting all ammunition. By mid-morning on June 17th, the Japanese counterattack was over. 31. Destroyed Japanese tanks littered the battlefield, counted by Marines walking through the area after the fighting stopped. Some sources suggest as many as 35 tanks were destroyed when including those knocked out by artillery fire beyond the immediate battle area. Perhaps 1,000 Japanese soldiers were dead, including many of the tank crews and the infantry who had advanced with them. For the Marines, the victory was significant but grim. They had stopped a major armored assault, but the cost had been substantial. The 2nd Marine Division's commander later acknowledged that if the Japanese attack had succeeded, it would have been fatal to the division's fighting efficiency. The battle had been close, decided as much by American firepower and Japanese tactical errors as by overwhelming superiority. But for Marines walking among the destroyed tanks afterward, examining the vehicles up close, a different truth emerged. The Japanese tanks were not the formidable war machines they had expected. A Marine officer called his men over to look at a destroyed Hargo. He pointed to the holes in the armor. They were clean, round penetrations where 50 caliber bullets had punched through. The exit holes on the far side were slightly larger, rough-edged, where the bullets had torn through after crossing the interior. You could put your fist through some of the holes. Inside the destroyed tank, the scene was worse. The cramped interior showed signs of multiple penetrations. The commander's position in the turret had no protective features, no armor that would stop heavy machine gun fire. The manual traverse for the turret consisted of a simple hand crank. The gun controls were rudimentary. There was almost no space to move. The hull machine gunner's position was a small cubby with minimal visibility. The driver had a crude periscope and a small vision port. Everything was cramped, crude by American standards, and utterly vulnerable to 50 caliber fire. Marines who had fought at Guadalcanal 2 years earlier remembered seeing Hargos there. At the time, with Marines equipped primarily with light weapons and no armor support of their own, the Japanese tanks had seemed threatening. But now, with proper equipment, with heavy weapons and their own armor, the Hargo looked exactly like what it was. A light tank from the mid-1930s, adequate for its original design parameters, utterly inadequate for modern industrial warfare against a peer adversary. The psychological impact on surviving Japanese tank crews was profound. Those who were captured, whose disabled tanks left them with no choice but surrender, had to grapple with uncomfortable truths. Their tanks were not just outmatched, they were obsolete. The equipment they had trusted with their lives offered no protection against weapons the Americans used as standard infantry support. Intelligence officers interrogating prisoners noted a consistent pattern in their responses. The Japanese tankers expressed shock at American firepower. They talked about the quantity and quality of American equipment. They mentioned the casual abundance of ammunition and supplies they had witnessed. Many expressed feelings of betrayal that their own leaders had sent them into battle with inadequate equipment while telling them they had technological parity. One veteran tank commander who had fought in China since 1937 told interrogators that he had believed Japan would win the war through superior fighting spirit and devotion to the emperor. After Saipan, after seeing his tank penetrated by machine gun fire, after watching American Sherman shrug off Japanese anti-tank fire, he knew that spirit could not overcome material disadvantages. Training and courage meant nothing when your equipment was fundamentally inadequate. These reports were compiled, analyzed, and sent back to commanders throughout the Pacific. The lessons learned at Saipan would inform Marine tactics for the rest of the war. Japanese tanks were not a serious threat. Standard infantry heavy weapons, particularly the .50 caliber machine gun, were effective against them. Combined with bazookas, 37mm anti-tank guns, and Sherman tanks, Marines had overwhelming firepower against Japanese armor. Word spread through the Marine ranks quickly. You didn't need specialized anti-tank weapons to engage a Japanese tank. Your .50 caliber machine gun would do the job. This knowledge changed how Marines approached subsequent island battles. The fear that came with facing armor, the concern about tanks breaking through infantry lines, evaporated. Japanese armor became just another target, and not a particularly dangerous one. The Battle of Saipan continued for weeks after the failed tank attack. Marines and Army troops fought their way across the island against fierce Japanese resistance. The terrain was brutal, ranging from flat sugarcane fields to swamps, to volcanic cliffs, to Mount Top Chow, which rose 1,554 feet above sea level. Fighting in caves, ravines, and gullies consumed men and ammunition. The island was declared secure on July 9, 1944. The victory at Saipan had strategic consequences that reached far beyond the island. With the Marines in American hands, B-29 bombers could reach Tokyo. The psychological impact on Japanese leadership was severe. Emperor Hirohito recognized that American control of Saipan meant Tokyo would be bombed. Prime Minister Hideki Tojo resigned on July 18. For the first time, Japanese media admitted the war was going poorly. The loss shook Japan's confidence in ultimate victory. For Japanese tank crews across the Pacific, Saipan was a turning point. Word of the battle spread through military channels. Tank units on other islands heard what had happened. They knew their equipment was inadequate. They knew American weapons could penetrate their armor, but there was nothing they could do about it. The tanks they had were the only tanks Japan could provide. Japan's industrial capacity simply could not produce modern tanks in meaningful numbers. The nation's factories were strained by years of war. Resources were limited, with American submarines cutting off access to raw materials from Southeast Asia. Strategic priorities focused on aircraft production for kamikaze attacks and on coastal defense artillery for the anticipated invasion of the home islands. Tanks were a low priority. Japanese engineers had designed better tanks. The Type 3 Chinu, mounting a 75mm gun. The Type 4 Chi-2, with even heavier armament. But these existed primarily as prototypes and small production runs. Only 166 Chinus were built during the entire war. 2 Chitos, none saw combat. They were saved for the defense of Japan itself. Never sent to the island battlefields where they might have made a difference. Meanwhile, American production capacity was almost incomprehensible by Japanese standards. The Detroit Tank Arsenal, built by Chrysler Corporation, was a purpose-built facility dedicated to tank production. In December 1942 alone, the arsenal's 5,000 workers produced 97 Sherman tanks. That was more tanks in a single month than Japan produced in an entire year. The arsenal was not alone in this remarkable production achievement. Fisher Tank Arsenal, built in Grand Blanc, Michigan, was another government-funded facility operated by General Motors' Fisher Body Division. Fisher produced over 11,000 Shermans in multiple variants, making it one of the highest volume producers. Like the Detroit Arsenal, Fisher could produce hundreds of tanks per month when operating at peak capacity. American Locomotive Company in Schenectady, New York, converted from locomotive production to produce 2,300 Sherman tanks. Baldwin Locomotive Works in Philadelphia produced over 2,200 tanks while maintaining locomotive production for the war effort. Lemure Locomotive Works in Ohio built the first production M4A1 Sherman, a tank named Michael that was shipped to England and still resides at the Borrington Tank Museum. Lemure produced 1,600 tanks before returning to full-time locomotive production. Pacific Car and Foundry in Washington State, Pressed Steel Car Company in Pennsylvania, Pullman Standard Manufacturing in Illinois, and Federal Machine and Welder in Ohio all contributed to Sherman production. 10 major manufacturers, plus countless subcontractors producing components, tracks, engines, radios, optics, and weapons. The industrial mobilization was unprecedented in human history. The Detroit Arsenal itself was a marvel of modern production engineering. Built on 567 acres in Warren, Michigan, the facility covered over 1.5 million square feet of production space. Assembly lines snaked through the building for miles. Massive overhead cranes could lift complete tank hulls and move them between workstations. The factory operated 3 shifts, 24 hours a day, 7 days a week. Workers included men who had been automotive workers before the war, bringing their manufacturing expertise to tank production. But they also included thousands of women, many of whom had never worked in heavy industry before the war. These women, often called Rosie the Riveters, welded armor plate, assembled turrets, installed engines, and performed every job in the plant except the heaviest lifting tasks. They proved that the nation's industrial capacity could be multiplied by tapping a workforce that had been largely excluded from heavy manufacturing in peacetime. By the time production ended in June 1945, American factories had built 40,934 Sherman tanks. Japan produced approximately 2,300 Hagos, over the entire course of the war from 1936 to 1933, when production ceased. The ratio was more than 20 to 1. But even that understates the disparity because American tanks were far more capable individually than their Japanese counterparts. Sherman tanks weighed 30 to 35 tons depending on variant. They had armor ranging from 51 millimeters on the hull front to 76 millimeters on the turret mantlet. They carried 5-man crews with dedicated positions for each role. They had gyro-stabilized guns that allowed firing while moving. They had radio equipment in every tank, enabling coordinated operations. They were reliable with tracks that lasted 2,500 meters compared to 500 meters for German tanks and perhaps 1,000 miles for Japanese tanks. The Sherman was not the best tank of World War II. It was outgunned by German Tigers and Panthers, but it was good enough and it was available in overwhelming numbers. In the Pacific Theater, where it faced Japanese tanks designed in the mid-1930s, the Sherman was more than adequate. It was overwhelmingly superior. For Japanese tank crews on subsequent islands, the pattern established at Saipan repeated on Tinian. In July 1944, 7 Type 95s were destroyed in counterattacks against Marine positions. On Peleliu in September 1944, Japanese tanks were dug into caves and used as stationary pillboxes, recognizing they had no chance in mobile warfare. On Iwo Jima in February 1945, Colonel Teki Nishi's 26th Tank Regiment buried their tanks in volcanic ash up to the turrets, using them as armored bunkers because the tanks provided more protection when stationary than when moving. Even used as static defensive positions, the tanks were vulnerable. 50 caliber machine guns could still penetrate the turret armor. Flamethrower tanks could direct napalm into open hatches and vision ports, cooking crews alive inside their steel coffins. Bazookas could penetrate the thin armor from any angle. The Hago, once a symbol of Japanese armored might, had become a death trap for its crews. On Okinawa, the last major battle of the Pacific War, the Japanese committed the 27th Tank Regiment to the defense. The regiment had 13 Type 95 Hagos and 14 Type 97 Kihara medium tanks, 27 tanks total. The Americans landed with over 800 tanks. The numerical disparity was 30 to 1. The qualitative disparity was even greater. On May 4th and 5th, 1945, the Japanese launched a major counteroffensive designed to drive the Americans off the island. Tank units were committed to support the infantry assault. The attack failed catastrophically. Most of the Japanese tanks were destroyed within hours, knocked out by a combination of Sherman tanks, bazookas, 37mm anti-tank guns, artillery, and 50 caliber machine guns. The survivors withdrew, having accomplished nothing except adding more destroyed hulls to the battlefield. In August 1945, when the Soviet Union declared war on Japan and invaded Manchuria, Japanese tank units in northern China faced yet another technologically superior opponent. Soviet T-34 medium tanks with their sloped armor and powerful 76mm guns vastly outclassed the Japanese tanks opposing them. In the Battle of Shumshu Island, part of the Kuril chain, Japanese tanks attempted to defend against Soviet amphibious landings. The Japanese had a mixed force of approximately 77 tanks on Shumshu, including Type 97s and some newer Type 1 tanks, with only 25 Type 95s. The Soviets used 45mm anti-tank guns, anti-tank rifles, and anti-tank grenades to devastating effect. The Japanese lost 21 tanks in approximately 2 hours of fighting. Soviet forces, experienced in armored warfare from years of fighting on the Eastern Front in Europe, made short work of the Japanese defenders. The experience of Japanese tank crews during World War II, particularly in the final years, was one of gradual, crushing realization. What they had believed about their equipment, about their chances, about their ability to compete with Allied armor was fundamentally wrong. And the moment of truth for many came not in some epic tank duel between armored champions, but in the terrible simplicity of watching machine gun bullets punch through armor that was supposed to protect them. For Marines who fought at Saipan and subsequent islands, the lessons were different, but equally profound. They learned that Japanese tanks were not a serious threat. They learned that proper equipment and overwhelming firepower made all the difference. They learned that their 50 caliber machine guns, which they had trained with and maintained throughout their service, were actually effective anti-tank weapons in the Pacific theater when engaging thinly armored Japanese vehicles. There was no glory in these lopsided battles. Marines didn't feel heroic shooting at tanks with machine guns and watching them burn. They felt a mixture of relief, pity, and grim satisfaction. Relief that they didn't have to face serious armor opposition, the kind their counterparts in Europe dealt with daily against German tanks. Pity for the men in those Japanese tanks who had been sent to die in equipment that offered them no real protection. Satisfaction that their weapons worked, that American industry had given them the tools they needed to do their job. After the war ended, some surviving Hargo tanks were shipped to the United States for detailed examination at the Aberdeen Proving Ground in Maryland. American engineers and armor specialists studied them carefully over a period of months. They measured armor thickness at multiple points on the hull and turret, documenting the variations. Front hull, 12 mm. Side hull, 12 mm. Rear hull, 10 to 12 mm. Turret front, 12 mm. Turret sides, 12 mm. Roof plates, 9 mm. Belly armor, 6 mm. They tested the quality of the steel using metallurgical analysis. The armor was face-hardened, a process that made the outer surface harder than the interior core. This technique was effective against small arms fire, causing bullets to shatter rather than penetrate, but it was ineffective against larger projectiles with sufficient energy to break through the hard outer layer and penetrate the softer interior. They evaluated the internal layout, taking detailed measurements and photographs. The fighting compartment provided barely 50 cubic feet of space for the commander. He had to stand constantly with no seat and no resting position. The turret ring diameter was just 1,200 millimeters, leaving minimal space for a man to work while also operating weapons, loading ammunition, and commanding the tank. The crew positions were claustrophobic to the point of claustrophobia. The driver had a space approximately 2 feet wide and 3 feet deep. His controls were simple, consisting of steering levers, a throttle, and a gear shift. His vision came from a small armored periscope and a direct vision port that could be opened in non-combat situations. The hull machine gunner beside him had even less space, confined to a small cubby with his weapon and limited ammunition storage. American tankers who examined the Hargos could not imagine fighting in such conditions. Sherman crews, by comparison, had a fighting compartment that provided over 150 cubic feet of working space. Each crew member had a defined position, with proper seating. The commander had a cupola with all-around vision blocks. The gunner had a telescopic sight and power traverse for the turret. The loader had space to move and access to properly organized ammunition racks. The driver and assistant driver, called the bow gunner in American nomenclature, had adequate space and vision equipment. Their reports confirmed what had been learned in combat and what mathematics had predicted. The Hargo was a light tank suitable for operations against poorly equipped opponents. It could function effectively in colonial warfare, in police actions, in suppressing resistance where the enemy had no serious anti-tank capability. It was not suitable for modern industrial warfare against the peer adversary with proper weapons. Any firearm more powerful than a rifle could defeat its armor. The 50 caliber armor-piercing rounds didn't just penetrate, they overpowered the armor completely, punching through with energy to spare. The internal arrangement was cramped to the point of being actively dangerous, even without enemy fire. The commander's workload, handling all turret functions alone, was unrealistic. The lack of radio equipment in 3 of every 4 tanks made coordinated operations nearly impossible. The hand-crank's turret traverse was exhausting and slow. The vision equipment was crude, leaving the crew largely blind to their surroundings. Every aspect of the design reflected the constraints Japan faced. Limited industrial capacity, resource scarcity, and design philosophy rooted in experiences against inferior opponents. The comparison with American tanks revealed the full extent of the design philosophy differences. Where the Hargo was cramped, the Sherman was relatively spacious, with enough room for crew members to move, switch positions if necessary, and work effectively even during extended combat operations. Where the Hargo had thin armor vulnerable to machine gun fire at close range, the Sherman resisted dedicated anti-tank guns at combat ranges. Its 51mm frontal armor, angled at 56 degrees, provided effective protection equivalent to approximately 75mm against anti-tank projectiles. Where the Hargo had a single-person turret crew performing multiple simultaneous tasks, the Sherman had 3 men in the turret. The commander could focus on commanding using his cupola with 6 vision blocks to maintain situational awareness and direct the crew. The gunner focused exclusively on aiming and firing the main gun using a telescopic sight with magnification and a power traverse system that could rotate the turret quickly and smoothly. The loader focused on maintaining a high rate of fire, pulling rounds from organized racks and loading them efficiently. The Sherman's 75mm gun had a muzzle velocity of approximately 2,400 feet per second with standard ammunition, giving it effective armor penetration against most targets it would face in the Pacific. The gun was stabilized in the vertical axis, allowing reasonably accurate fire even while the tank was moving, a capability the Hargo completely lacked. The Sherman carried 97 rounds of 75mm ammunition in protected racks. Compared to the Hargo's 130 rounds of 37mm ammunition stored loosely throughout the fighting compartment, communication capabilities differed dramatically. Every Sherman had a radio, usually an SCR-528 or STR-538 set, allowing tank-to-tank communication and coordination with infantry and artillery. The Hargo had radios in only 1 tank out of 4, leaving the other 3 to follow visual signals, a system that broke down quickly in combat when smoke, terrain, and enemy action made visual contact impossible. Vision equipment on the Sherman included periscopes with replaceable prisms, direct vision ports with armored covers, and a commander's cup that provided all-around observation. The HGO had crude periscopes and small vision ports that provided minimal situational awareness, forcing commanders to expose themselves by opening hatches to see what was happening around them. Every aspect of design, from ammunition storage to crew comfort to fire control equipment to communication systems, was better on the American tank. But the most telling difference was not in the individual tanks. It was in the numbers and in the industrial systems that produced them. The United States had built an economy that could wage industrial warfare on a global scale. Factories that had produced automobiles now produced tanks at rates that would have seemed impossible in peacetime. The Detroit Arsenal alone, in its peak production month, produced more tanks than Japan produced in a typical year. Women who had never worked in heavy industry welded tank hulls and assembled turrets. Engineers constantly improved designs, incorporating lessons learned in combat. The supply chain delivered raw materials to factories and finished tanks to ports with clockwork efficiency. Merchant ships carried Shermans across both oceans to battlefields in Europe and Asia. Maintenance units in the field kept tanks operational, cannibalizing damaged vehicles for spare parts and returning repaired tanks to combat within days. Japan had never built this kind of industrial system. Its economy was strained by years of war in China before the Pacific War even began. Its factories lacked the automation and mass production efficiency of American plants. Its access to raw materials, particularly after American submarines began sinking merchant shipping, was increasingly constrained. The nation that had challenged the world's greatest industrial power was discovering the true cost of that challenge with each new battle. For the Japanese tank crews on Saipan that early morning in June 1944, and for every Japanese tanker who fought in the Pacific afterward, the lesson was brutal and clear. They were obsolete. Their equipment was obsolete. Their tactics, developed for a different kind of warfare against different opponents, were obsolete. And there was nothing they could do about it, except continue fighting with what they had, knowing that survival was unlikely and victory impossible. The Marines on the other side learned different but equally important lessons. They learned that industrial might matters in modern warfare, that having better equipment in larger quantities makes an enormous difference, that courage and training and fighting spirit, while important, cannot overcome fundamental material disadvantages, that the factories back home in Detroit, Pittsburgh, Cleveland, and dozens of other industrial cities were as important to victory as anything that happened on the battlefield. They also learned something specific and immediately practical. When you encounter a Japanese Hargo tank, you don't need to call for anti-tank support, or airstrikes, or artillery, though all of those are available if needed. You can engage it yourself with your .50 caliber machine gun. At close range, under 200 yards, the armor-piercing rounds will penetrate. Aim for the engine compartment, the sides, or the turret. The bullets will go through, disabling the tank and likely killing or wounding the crew. The weapon that was designed to shoot down aircraft and destroy light vehicles works just fine against Japanese armor. It was a small tactical lesson in a massive war. But for the men involved, for the Japanese tankers who died in their inadequate machines, and for the Marines who destroyed them with heavy weapons, it was a moment of absolute clarity. This was not a fair fight. This was not an even match. This was modern industrial warfare, where one side had overwhelming material superiority. The outcome was never in doubt. The Hargo tanks on Saipan and on every other Pacific battlefield where they fought represented more than just obsolete armor. They represented the gap between what Japan needed and what Japan could produce. They represented the impossible situation Japanese soldiers faced, ordered to fight a superpower with equipment that was never designed for that kind of war. They represented the consequences of strategic decisions made years earlier, to prioritize naval and air power over ground forces, to assume that fighting spirit could compensate for material inferiority, to believe that early victories indicated long-term viability. When those first 50-caliber rounds punched through Hygo armor on Saipan, they proved something that would echo through the rest of the Pacific War and into the post-war analysis of why Japan lost. They proved that in industrial warfare between modern nations, production capacity matters, design philosophy matters, resource allocation matters. No amount of courage, training, or tactical skill can overcome a 10-to-1 numerical disadvantage, combined with generational gaps in equipment quality. The Japanese tank crews who climbed into their Hygos that morning in June 1944 believed they were going into battle with reliable, capable machines. By the time the sun set on June 17th, those who survived knew the truth. They had been sent to fight with armor so thin that machine gun bullets went straight through. They had been given equipment that was adequate for the war Japan planned to fight in the 1930s, but utterly inadequate for the war Japan found itself fighting in the 1940s. And there was nothing they could do about it, except continue serving, continue fighting, and continue dying in machines that could not protect.